Hey everybody, thank you for joining me for another episode of Earthly Headlines. I've been meaning to get a video out about this a few days ago when the story came out, but apparently that smoking gun crater responsible for the Younger Dryas is it's been found. Now, the reason why I say allegedly is because the jury's still out on the timing of when this impact hit. They know for sure it's pretty young though, less than 100,000 years. After looking at what they found and how far they've come before actually announcing all of this, I think it's pretty certain that these are one of the impacts responsible for, or at least contributing to, the Younger Dryas event. Remember, the Younger Dryas event took place over a period of a couple thousand years plus. And there were multiple impacts, according to the theory, not just one. So, although this one is huge, it's way big. I think it's way bigger than Washington D.C. It's about almost 20 miles in diameter. Compared to other Earth-changing asteroids, it's pretty small still. But I mean, it's still ridiculously strong enough to change and alter the course of history of the Earth. The interesting part about this story is how the scientists got to where they meant to go, meaning how they came across the evidence and the crater and all the circumstances that they needed in order to make this happen. The guy in question, his name is Kurt. I think his last name is Kjaer. Kjaer. He saw the Hiawatha glacier, which is basically this block of ice that moves, but it doesn't move like a normal glacier would. It's moving in a semicircle, kind of like this. So it was as if there was some sort of, it was spilling out of a basin pretty much, like as if it was peculiar enough to warrant questioning what was going on underneath the surface of the water that it was floating on. With this hint, he started working on uncovering what that thing was. So basically, long story short, he finds that there's a 31 kilometer wide impact crater right underneath that ice sheet. From there, they found what you would call impact spherules, impact proxies rather. The way the crater was shaped was indicative of a very recent impact, because normally a crater that eventually, when it becomes old enough, a crater smooths out and it looks like the ones on Mars or on the moon you see, which are very smooth. But this one was still, the erosion hadn't kicked in all the way yet, so there was still jagged stuff right in the middle of the crater. They just found more and more hints to make them look more into it and keep looking into it. So the stars did kind of align for this discovery to take place for sure. But again, the wild card is, when exactly did this happen? And we'll get into some of the contrary points of view as well. I did a few videos on the Younger Dryas already. If you guys don't know, basically it's a climate episode in which when we were coming out of the Ice Age, there was suddenly, from the Greenland ice core data, they found that around 12,900 to 11,600 years ago, there was a huge climate anomaly where it suddenly got hot very quickly, then it got super cold again. We were coming out of the Ice Age, it was warming up. This impact supposedly happened, plunged us back into the throes of the Ice Age, and then we resumed the warming coming out of the Ice Age again a few thousand years later. It's puzzled a lot of people, a lot of scientists. A lot of scientists also thought it was BS and that it was just an anomaly and nothing more. But now, since this has come up, this Hiawatha crater has come up, more talks about the Younger Dryas has come up as well. First of all, let's talk about what it would have looked like. the Hiawatha, the meteor that hit it. So anyone within 500 kilometers, it would have looked like a giant white fireball, bright 3 or 4 times brighter than the sun. So think about like Dragon Ball Z, right? Just in the sky, you just see this thing in the sky that's super bright. You can't even look directly at it. Streaking across the sky, then it hits an ice sheet. By the way, it's traveling about 12 miles a second. So it's packing a kinetic punch. Straight through the ice sheet, vaporizes everything in its path, straight through the bedrock, and then until it leaves this nice crater. All the water becomes vaporized, the smoke, stuff gets ejected into the air. Eventually the sky blacks out, blocks out the sun. It starts raining mud and water for probably months and months afterwards. And also huge scale fires from the embers generated. The embers carry across, and it just ignites everything, all the advancing forests. But which, by the way, there were advancing forests because we were coming out of the ice age, and then suddenly they turned into ice tundra for a few thousand years. So basically, the Earth was making warming progress gradually, and then it just got set back because of this, according to the Younger Dryas impact hypothesis. Hundreds of kilometers away, still would have felt the shock wave. They would have heard the thunderclap. They would have felt the wind. So a lot of the description of this is very biblical in a sense. Rock debris rained down. There was no sun for a while. It was a serious thing that killed a lot of life on land, especially in North and South America. It sent a bunch of meltwater pouring into the Atlantic Ocean, disrupting the conveyor belt of currents between the Atlantic and the Arctic Ocean. Needless to say, all the shorelines get redrawn because the water level rises 400 or so feet, something crazy like that. The English Channel, which wasn't there, is suddenly there. Sundaland is no longer Sundaland. It becomes all those the archipelago of islands that we know now near Indonesia and New Guinea and northern Australia. So all this stuff happened. So a new world happens basically. So the Younger Dryas, the scenario, I guess about 10 years ago, there was talk about it for a while, but about a small group of scientists were really trying to propose it to the scientific community in the form of papers and lectures and stuff like that. And they're trying to explain that cooling event that was over 1,000 years long, like I mentioned earlier. But people were leery. They didn't believe the evidence. They thought it was too far-fetched. It wasn't sufficient enough to explain the disappearance of the Clovis people because they were already nomadic. It didn't explain the end of the megafauna because the megafauna were already dying out. This is what they were saying. I don't necessarily agree with them, by the way. I think it definitely at the very least contributed to the death of the megafauna and erased life or human life for the most part on North and South America. And we did a video I did 2 videos about the genetics and the peopling of the North and South America. And around the time of this impact is when stuff gets squirrely. I mean, there are a lot of anomalies going on in this time frame, and I don't think they're all independent of each other. I think they all have something to do with each other. And I think a lot of people think the same way. It's just that some people are more cautious than others in the scientific community, and they don't want to they just want to ride the fence until some smoking gun comes out. And apparently this Hiawatha crater is a smoking gun for a lot of people. But still, there are some people who aren't. It's not that they're not accepting it. They just don't. They're just leery of it. They just don't buy it. They don't think it has anything to do with what was going on in that weird cooling event 12,900 years ago. So James Kennett, one of the marine geologists at UC Santa Barbara, he was one of the first proponents of the Younger Dryas impact. He feels vindicated. He says, unequivocally, I predict that this crater is the same age as the Younger Dryas. A lot of people agree with him. Some people, though, and I think this is a weak rebuttal, they think, oh, statistically, the impact the size of Hiawatha only occurs once every few million years, so the chance of one 13,000 years ago is small. Okay, but it doesn't mean that it didn't happen or it can't happen. Like, it happened in the past. It probably will happen again. So I don't know. It's just a weak argument. It's just statistically. It's like, well, yeah, it was due then. Only every few million years. Yeah, the last one, at least that big, was a few million years ago. It's ridiculous. It's like the same argument. It's like the people who say that Yellowstone won't blow up because it already blew up and it doesn't blow up very often. It's like, yeah, but there's seismic activity going along. There's all these telltale signs of something going on with the tectonics and all the earthquakes that are happening like clockwork. Anyway, I don't know. I just thought that coming from a scientific standpoint, I just thought that was a weak argument. Let's go back to 2015, how Kyer decided to just jump in and all the steps that led to today, to the announcement today. So first, they saw this hole, and based on the bedrock topography, they thought there was a hole under here. There's like the ice steps and surface. There were variations on the flow patterns. Like I said earlier, it was floating in like a semicircular pattern. So that was one of the first hints. Another hint was a 20-ton rock, which was basically made out of iron, a meteorite. It was a chunk from a larger meteorite, which was found, I think, in northwest Greenland, this is the Hiawatha crater right here. So yeah, it was found near the crater. Inuit people used the iron they found around there as tips of harpoons and tools. So that's the second hint. They found all this iron and these iron meteorites. And then so Kyer decides, okay, I want to map out this area. We need some radar. So Joseph McGregor, he's another member of this team. He's a glaciologist for NASA. And so he found that this is really interesting. So he found that NASA aircraft often flew over the site on their way to survey the Arctic Sea. And the instruments, on the way out, they would just leave them on in test mode. So they had a whole backlog of radar data already. So that saved them a lot of time and money. So they looked at the radar pictures, and they more clearly showed what looked like the rim of a crater. But in the middle, the images were still muddy. It was fuzzy. They couldn't really make it out. But they did have that rim of a crater, which is a telltale. The way the crater is formed is very obvious if you have a clear image. And so they have these things called peak rings. So they wanted to get a clear image of those. So they needed a better radar, a more dedicated radar mission, so to speak. They wanted to really get in there. And coincidentally, there is this institute called the Alfred Wegener Institute for Polar and Marine Research, based in Germany. They just so happened to purchase a next-generation ice-penetrating radar. So they mounted that on a spacecraft, and they went ahead and did that. And they launched, but no, before they could do that, though, they needed a base of operations to launch it from. So they persuaded somehow the U.S. military to let them work out of Thule Air Base, which is right here, a little bit southwest of the impact site. And they granted them permission, and they're notoriously stingy with stuff like that, the U.S. military. But somehow they were able to get it, and boom, the stars aligned, and then they used the radar. Here's a picture of the propeller plane, or part of it anyway, over the glacier. And the radar revealed 5 prominent bumps in the crater center, indicating a central peak rising some 50 meters high. And remember, if there's a central peak, that's pretty indicative of a recent impact. And the crater bottom is jagged, like I said earlier. It's not smooth yet. It will get smooth in thousands and thousands, probably millions of years it will. But the erosion had not gotten there yet. So that's how early this was. There are a lot of other signs too, which we'll get into. The other thing the radar signals showed, they also showed the deep layers of ice were jumbled up. Another sign of a recent impact. So imagine something hitting the ice, and usually the ice will break up, and then and along with the earth, and it leaves a jumbled mess on the ground. It hadn't had time to even not reorganize itself, but just to smooth out. That not enough time has passed for that to even happen yet. So that's how this is parts of the reason why I think it did happen 13,000 plus years ago. No older than 20,000 years ago for sure, along with some other evidence as well. They found glass grains forged at temperatures higher than a volcanic eruption can generate. So the only way that these glass grains can be made is by comet impact or nuclear explosion. And no one's detonated bombs around Greenland, to my knowledge. And also they discovered shocked crystals of quartz. And that is, for a lot of people, that's the smoking gun. That's what makes it really compelling. And that's what made a lot of the scientists go, okay, shocked quartz, this has to be a comet impact. There's no doubt about it. But it doesn't necessarily answer when, but it definitely answers that it was a meteor. And it definitely hit, that this is a crater, 100%. So that is over half the battle right there, because for the longest time in the conversation, they were just trying to accept that point. And a lot of people were like, there's no smoking gun. That's BS. You can't argue. They wouldn't even engage in the argument because of that. But now this changes everything. So here's a nice infograph, or I guess, it's like a nice graphic here. So like I said, the Hiawatha crater is huge. No doubt about it. It's gigantic. But compared to these, it's really small. Anything remotely as big as the Hiawatha crater, the last time it happened was 35.5 million years ago. The Chesapeake Bay crater, which happens to be around the same area. So go figure, right? If we're on some weird orbit and like clockwork, we pass through this meteor field or asteroid belt, whatever, it makes sense that it's cyclical, that maybe in another 30 whatever million years another impact is going to hit us, because we're passing through we're in the same neighborhood, so to speak. It makes sense that they're spaced out, because it seems to be every 30 million years. Because look, before the Chesapeake Bay crater was an even bigger one, the Chicxulub crater, the one in Mexico, the one that wiped out the dinosaurs, 66 million years ago. So 31 million years before the Chesapeake crater one, and then 35 million years later was this one. And these are just the ones that we know about, though. There might be a bunch. Under Greenland, actually, there might be more craters. Actually, some scientists are certain that there are craters. So here's the ice-penetrating radar from the airplane. And here's the grit within the ice. So grit meaning just all the debris from the impact. And then look how thick the ice is. Jeez. And this is the peaks that the radar detected. And this is a hole right here. I mean, that looks pretty... It's telltale for sure. That's the word I'm looking for. Telltale. It's like a murder mystery, and we just found like the blood stains from the stabbing or something like that. It's just incredible, dramatic unveiling of this evidence that a lot of people suspected was there. Incredible stuff. And then I already mentioned the fiery embers and projectiles would have set forest on fire, and that's true because it's happening in California right now. I mean, the California fires are happening as we speak, and how the embers traveled from miles and miles. It traveled through the air and landed on some dry brush miles away from where the fire started, and that itself started a whole nother blaze. So those embers, it's not a joke. If you have the right conditions, the fire can spread and burn very quickly. It can get out of hand very quickly if it's not contained. And those embers can be carried far away. They don't just burn out so easily. When we're talking about billions and billions and billions of those fiery particles. Another thing the sediments contained were geochemical traces of extraterrestrial impact, mainly iridium, which was the main thing that they found. Previous comet impacts, they found traces of iridium, and that was the smoking gun for other cases. So that hallmark is consistent in the Hiawatha crater as well. And here is the shocked quartz here, and you can see how the discoloration here is very indicative of some sort of shock wave from incredible amounts of kinetic impact. So they looked at ice core data from other parts of Greenland, and around the time, anything past 11,700 years is perfectly layered, but in the older disturbed ice, the reflections mysteriously disappear. It was pretty self-consistent that the ice flow was heavily disturbed at or prior to the Younger Dryas. So something happened 12,800 years ago that made it look the way it looked, and the layers, which was pretty consistent, suddenly there's nothing after that. It's just completely off the charts. And even in the ice core data, they're finding it out. So now we have a bunch of different data. We have the ice core data. We have the sea levels, the rising sea levels, the disruption of the current, the warmth of the North Atlantic and the Arctic. We have the soil. Oh, I forgot to mention this. So when the embers flew and then everything was burning down, essentially all the forests were burning down in north, basically this continent-wide fire, we had the black mat layer, right, which is this coal and soot layer dating to this time. So that's basically geological sediment data. We have the ice cores, we have the iridium, we have the platinum. So we have the central peaks. There's a lot of information, there's a lot of evidence that coincides together to build this giant case that the Younger Dryas, at the very least, there was a comet impact that either spurned on the Younger Dryas or it happened at the same time coincidentally, but I don't think it's a coincidence. I think this happened and then the Younger Dryas happened. There's definitely a connection. So this is Kyer right here in 2016. He's looking for evidence in the impact sand. So he was digging up iron and all kinds of different impact proxies that were existing. How many years after the fact? 13,000 years after the fact? 14,000 years after the fact? So I don't know. I know I was a little bit late to the game in this. I'm pretty sure you guys have read up on all this already. So let me know your 2 cents. Do you guys think this had anything to do with the Younger Dryas? Do you guys think that there were more impacts? I mean, apparently the impacts spread not just North America and Canadian ice sheets, but also Western Europe, even as far east as Turkey. So let me know what you guys think about this. I'm very curious. What have you guys read? Are there any opinions that don't agree? I mean, don't agree with the timing? I mean, because it's pretty irrefutable now that there was an impact at the Hiawatha crater. I mean, it's a crater. There's no doubt about it. And if you guys think it's older, then how do you explain the lack of erosion in the crater? Why is everything still jumbled up inside the crater? And why is that glacier not in its natural pattern? Why is it still disturbed in this weird anomalous movement? Just some food for thought. Let me know what you guys think, and I'll see you guys on Monday.